So this is an alkyne, right? And in the category of carbon hydrogen bonds, remember this is we have a carbon right here. In category of carbon hydrogen bonds, these are the most acidic with a pKa of around 25. And this is useful because if you treat it with a sufficient base, typically it is a sodium amide. Sodium amide. This is our acid, and acid base. We can set up a acid-base equilibrium in which we deprotonate the acid. 2, 3. Now it's a carbon with lone pair and negative charge. Plus the conjugate of our base is NH3. Okay? So that's our conjugate base, conjugate acid. And when we look at pKa of ammonia, okay? Ammonia, the pKa is about 38, if I remember correctly. Okay, verify that. So now, with a 13 units of pKa difference, we have this equilibrium heavily favored to the right. Okay.
So it favors the higher pKa?
Yes, the higher the pKa, the weaker acid.
Yeah.
And equilibrium always favored weaker acid. Okay, let's put it down.
So it'll favor the formation of ammonia?
Yes.
Okay.
But what's important to us is now we have a carbon with a negative charge on it. Okay. That is a nucleophile. This is a very narrow and by extension very useful category of nucleophiles. Because with carbon nucleophiles you can build longer, bigger chains. You can build carbon complexity to a molecule. Okay?
So you could basically make this alkyne add on to another carbon chain.
Let's say if I take this nucleophile, our deprotonated alkyne, and I treat it with ethyl bromide, I get a substitution reaction. I have a nucleophile, electrophile, SN2 gives me 1, 2. Okay?
Yes.
And I just build complexity into the molecule. Right? So together with alkynyl anions, that's the same category you would have your Grignard reagents. Okay. In fact, you can take that type of molecule, treat it with magnesium, and get a magnesium bromide.
So you're saying this is the way to do it when a acid-base reaction wouldn't work?
Maybe another way, if you wanted to generate alkyne nucleophiles, you do acid-base reaction. Grignard is much broader. You can start with any bromide and make carbon nucleophile.
Oh, okay.
This is not, the top reaction is only restricted to alkynes because of their lower pKa.
Yeah.
This one is not restricted to anything. The only condition is you need a halide and magnesium. Okay? But if it's the same category of reagents.